Well, hello everybody. Thank you for joining. Today I am joined with Allen Helton, who is an AWS serverless leader and a Postman leader, who's going to show us a little bit about what he's been doing with MCP and Kestra in the world of observability.
First of all, happy to be here. Thank you for having me on. So my name is Allen Helton. I'm an AWS serverless hero and Postman leader, which are both just accolades for doing cool stuff in public that kind of pushes the mold. And a lot of the work I've been doing recently is with AI, and the big hype train that we're seeing right now in AI is the Model Context Protocol, or MCP. And so one of the things I've found a lot of issues with MCP, with that protocol in general. Everybody's using it right now, and we're rushing into it, kind of putting aside a lot of things that need to be thought of in the forefront. Security and misuse of APIs. A lot of people are using MCP servers as API wrappers. I think that's probably an issue. But one of the big things that we haven't really been talking about is observability into the servers. Now, these servers really are just another way to say tools that AI can use, tools being functions or just like literal code that these LLMs or these large language models can call when they reason, oh, I should probably do something based on the request I was given. I haven't really seen a whole lot in observability to figure out, like, what are the latency of these tools? How many of them are failing? How many of them are being used? Because publishers or creators of the tools need to know who's using what and is that going well. So I used Kestra to kind of build this async observability tool, more or less. We'll call it that, to give you those insights. And this is really, it's a POC. It's not an absolute production ready thing. There's a little bit of things that would need to be tightened up, but the proof of concept, I think, is pretty solid. We can see a really cool insight when you're just having a conversation in a chat window.
And the thing I thought was quite interesting was you'd never touched Kestra before. This is your first time using Kestra, and you were able to get scrap together a demo relatively straightforwardly. Well, it didn't take you too much time to get something working.
Yes. Now, I will say yes with a caveat. I made it more difficult on myself. Kind of intentionally, not kind of intentionally. My objective was to build a workflow without writing code. Now, being an AWS serverless hero, I am in the AWS lands a lot. And specifically, one of the services that I use probably 9 times out of 10 whenever I build a project is AWS Step Functions, which is a workflow orchestration service inside of AWS. And my goal always in there is, don't write Lambda functions. Can we chain things together from step to step without writing code? I brought that same mental attitude to Kestra. Can we do anything, or can we do this whole workflow without writing a script that runs a container to basically parse JSON or do a little bit of data transformation? So I was able to figure everything out without writing any code, if you will. And I'm going to put code in quotes because I know that is a semantic debate with a lot of people, is YAML code. Some people say yes, some people don't, is configuration code.
Yeah, it's a funny one because YAML is, like, if you sort of look at very basic YAML, you look at it and you go, well, that's not code. It's just showing some data. But if you look at how Kestra does YAML, which you could say is almost maybe too far in the other direction, you've kind of turned it into a programming language. In some scenarios, that's great. In other scenarios, you go, I should have actually just used a programming language in this case. It's like you've got to know where the balance is, right? Sometimes you want to keep things entirely, like you say, it can get messy if you do some things in code, some things in the YAML, and then it kind of gets difficult to maintain. So it's kind of best sometimes to try and focus on doing one or the other. But there are some scenarios where it's like, actually, this task is just easier to do as a Python script or as a shell script or something like that. I think you didn't quite reach the limit of where it makes sense to switch, but maybe you feel like you got close.
At times I did. I thought about, maybe I just hang up my JQ hat, because I use a lot of JQ to do the JSON manipulation, and just, do the simple math or the array parsing and math in JavaScript. But I was like, no, we'll do it. We got it.
Nice. Okay. So you've built these workflows in Kestra. You also built a quick MCP server in, I believe it was TypeScript in
I did.
Node.js.
Yes. Yeah,
Wonderful.
TypeScript. Hmm.
Would you like to give us a quick demo of this working?
So I know a lot of people don't like looking at code, so I think I'll probably just start in Claude and show the tools that are available from this MCP server. So I have an MCP server, and again, if you're not familiar with the protocol, I'm just going to redefine it as a set of tools that large language models can use. And a tool is code that it runs. Now, historically, what we've been doing, we being the collective consumers of ChatGPT, of Claude, of these large language models, is we know we have a lot of conversations with them. And typically what's been happening is it's just a back and forth. Let me ask a question, let me get an answer. But with this model context protocol, it's made it a lot easier to be able to give this question and answer the ability to run code for you. So I built an MCP server, collection of tools that allows Claude to do things for my garden. I have a massive garden, and I have, I don't know, probably 25 different beds. I have well over 100 plants in the garden, and I try to track and observe, what am I harvesting? What do the plants look like? What's the soil moisture like? What is the amount of sun that each bed gets? And you combine that with the reasoning capabilities of an LLM like Claude, and you can say, well, hey, for the melon patch, do you think it's a good idea if I plant uh, cantaloupes in April? And so it can go and it can look at all this information that it's stored, specifically about my garden, and say, no, it's already too crowded. It's too late in the year. You don't get the right kind of moisture, all that fun stuff. So real quick, I'm not going to do a demo of Claude itself because we probably have seen those 100 times, but I will show you, if you click on this hammer, it shows all of the different tools that I built in this MCP server. It has what the tool name is, and it has a description of what those things are, of what they do. And the LLM or Claude is actually looking and reading all these things and figuring out what it has the ability to do when I'm talking to it. So if I go in and I say, what's in my garden? What it's going to do is it's going to reason. It's going to look at those tools and it's going to say, okay, well, let's see what's in your garden. It's going to ask me for permission because this is running locally on my machine. It's going to say, can I run list beds? And I say, yeah, of course you can. So it's going to go in and it's going to list all of the beds that it has. You can see it's in and out, and then it's going to go and transform that into meaningful text that I can see. So if I want to say what's planted in there, it will again reason. It has the history, it has the memory of everything that we've already done. And so it's going to be running this tool for get bed, and it's going to run that and iterate over all of the beds that it just pulled from that list beds, and then aggregate a really nice answer for me and spit it out in natural language so I can communicate with my garden. So it's going to do this
Very
a few
cool.
times. Yeah, it's going to do it a few times because I have a few beds in there. This is not exhaustive. This does not represent my full garden because that would take a long time to set up. But it's going in and it's iterating. Here's the stuff that you have. Here's when it was planted. And then it also has some of the observations that I've recorded in there. So pretty neat as far as like how you can extend these large language models. So that's the MCP server interacting with Claude. Now, what you don't typically see is analytics behind this. As a publisher, so let's say I marketed this and I own this code that Claude is running, and I want to make money off of it. I want to see what are the most popular tools. What's being used the most? Because generally, if I have a tool that's being used 90% of the time and all the others combined are 10% of the time, I want to invest all my time and attention in that 90% one. So I want to see what's that breakdown. Is it performing okay? If it's lagging and maybe I'm running in a serverless environment, maybe that Lambda function that's backing the code is costing me a lot of money because it's super slow. So I want to be able to see kind of what's the breakdown. And to do that, I have Postman. Let me bring Postman onto the screen. And there's a lot that I'm glossing over that we can come back around and talk about. I'm just going to run the demo first. And it's going to pull out the metrics that Kestra has been aggregating and saving for me behind the scenes every time a tool is called. So I'm going to hit send, which is going to load all the metrics, but I have a visualization on here. So I can click on that little visual.
Cool.
Isn't this nice? So this is showing me the tools that have been used and their latencies. And so this is showing us, what is it showing us? Average P99, which is what's the 99% slowest call, and then the actual slowest call. We don't have a very big sample size, so generally that P99 is going to be the same as the slowest, but if we're using this tens of thousands or hundreds of thousands of times, those will be different. So you can see this was the list beds, that was the get bed, and then down here at the bottom, I have this nice table that aggregates all the data and shows us, well, how many times is each of these being run? Are they successful? And then show me a number format. What's this? So if we go back to Claude, and let's just use one more tool. What have I harvested this year? Claude is going to go in, it's going to say, okay, well, I know I have a tool for list harvests. There it is. Say allow. So it's going to go and call that. That tool is going to ping Kestra. It's going to run through my workflow. And then that's going to come back. If I hit send, now we can see that list all harvest is in here. And man, that's way faster than everything else. And you can see that there it's in this list now with how many times does it run, how many times was it successful. So pretty neat from an end-to-end, just kind of surface level demo of what we see.
That is very cool. How long has Postman had this visualization feature?
Ooh, I don't want to be quoted because I don't want to be wrong, but I want to say like 4 years.
Okay. This is very cool. This is one of those sort of like hidden secrets that like I use Postman all the time, but I've never realized that you can just visualize the data it gives you. That's lovely.
Yeah, and what's super nice as well, it's using handlebars and HTML to basically parameterize and generate this page. I'm not an expert in either of those things. So what I did was I used PostBot, which is their little AI chatbot, and I just said, visualize this response. Create meaningful graphs for me based on the response, and it did it for me. Wow. I didn't have to write any of that.
That's great. That's great because people just want to see it visualized. They don't want to have to spend ages making it look pretty. They just want to be able to see what the data's showing, right? And this does that. Sounds like pretty effortlessly.
It was. This was the fastest part of the project by far. So do you want to talk a little bit about what Kestra's doing with all of this?
Yeah, so basically, all this data, right, is getting processed every single time you talk to Claude, right? And so the question is, how is Kestra processing this? Basically, every single time you have a conversation with Claude. I like what you've done here. So your first workflow, which is, I believe it's the metrics one. It's the metric webhook one. Mm-hmm. Yeah. So basically, this webhook gets triggered every time you have a conversation with Claude, and then sends a bunch of data about what you're having a conversation with, right? And if you click edit the workflow for a second, so we can have a little look at the webhook itself. Basically, this workflow is validating that. Maybe I got that wrong. I think it might be the other one. But basically, this one's getting the body from your webhook with all the data from Claude and basically checking that the data is valid before it then sends it to another workflow to then actually do something useful with that data.
Exactly. Yes. And I designed this in a way, I have deep serverless roots. And one of the big things with serverless development, and I'm just going to caveat that and say with distributed systems development, not necessarily serverless, but with distributed systems, is you have to design for idempotency. So you have to design for retries, and you have to design for maybe accidental duplicate sends. So an idempotency check is going to basically check to make sure, have I already done something with this data that's coming in right now? When I'm doing metrics visualizations, especially at the low scale that I'm working on,
Mm.
I really don't want to see the wrong numbers. So if I call list beds, that tool, one time, but somehow it got retried 3 or 4 times, I don't want to see that data be
Mm.
visualized as 4 times, right? That's going to skew everything. So this item potency
Mm.
check basically says these metrics I'm representing with this unique identifier. I pass that over to Kestra, and Kestra is saying, have I seen that unique identifier before? If yes, you're out. If no, let me validate the data. Let me make sure you have everything that I expect. And if you do have everything that I expect, I'm going to succeed and end the execution. If you don't, I'm going to fail the execution. So that's kind of that first validate webhook trigger. Really, my purpose on that one was to guarantee I have super quick async responses when I'm hitting this webhook from my MCP server because I don't want to wait.
I really like that you separate instead of just making it one long workflow that does all these checks and then validates the metrics. You've broken it into two workflows, which means that you can see that metrics is run and metrics webhook is run, and basically they're being run because one is calling the other. But if metrics webhook fails, that it's easy to see that that's why it failed, right? If you just have it all combined in one, you'll just see that your metrics flow failed, but you'll have to dig into it and spend time figuring out, like, did it fail because there was duplicates or did it fail because of some other issue, right? So I like that. I like the design there, and the way that you've done that is if you click into the metrics workflow for a second. What I like here is right at the bottom you're using a flow trigger to start this, which and you're also checking that the your previous flow, which is metric webhook, succeeds before the flow trigger starts. So and then you also get a load of data from that trigger. So a lot of the data you can see there is already from the webhook trigger. And then you can then pass that to this workflow, which is then doing all of your code inside a YAML without using code.
Yes.
Which I would be curious to have a look at in a minute, to then have this workflow process that. And then if that fails for some reason because something's, I don't know, not in the format you're expecting or whatever, then it's easy to see which part of the full process, right, failed. And if you click on dependencies on the top right, you can visualize quite nicely that the metrics webhook is triggering the metrics workflow. So you can see that connection between the two.
Yep. Yeah, that was super nice. Flow triggers were nice.
Good. I'm glad. We kind of jumped over the webhook one a little bit. You're basically using lots of expressions here to check if data generated from tasks, which we call outputs, are the values you would expect, such as is the HTTP code 200? If it isn't, then fail the workflow. Let's not continue. And you're also checking some of the data from the webhook trigger itself. So I can see you're checking some of the headers. Also, you're passing in some of the headers to make more requests. Could you talk a little bit more about what you're doing here with Memento and how that sort of plays a key part?
Yeah, absolutely. So I need a remote centralized data store for everything that I'm doing with Kestra. So I figured why not use Memento? I work for Memento. We have a really easy to use cache with an HTTP API on top of it. So let's just use that. And what I really like about using Memento for something like this is that since this is just observability data and higher order metrics, I don't need to keep this stuff forever. So I can just throw
Mm.
it into a cache and have it automatically expire after X amount of time, and data is cleaned up for me automatically. I don't have to handle any of that. I'm just shoving it into the data store. I can put Kestra behind a load balancer. I could have 10,000 of these running, and they're all going to be pointed to the same remote data store and work in a thread safe way, which is super convenient because all I'm doing is using a couple of API endpoints to push that data in. It's especially useful as well for item potency checks because item potency headers are kind of the keys for have I seen this data before? And that should not live forever. That should live within a
Mm.
specific window. In my case, I said 5 minutes. And after that 5 minute window, it's fair game to use that header again. It's likely won't ever be used again because I'm just generating random UUIDs. But
Yeah.
the principle's there. So I'm using Memento to store the item potency keys. That's where I'm going and checking, hey, do I have this in the cache? If I get that result back with
And it
yes,
exists.
yeah, does that exist? Yes, then we're out of here. I'm not going to continue processing from here. This this HTTP request is also extremely fast because it's a cache. Like we're talking
Mm.
round trip in 30 milliseconds. So it's extremely fast to do your data checks. Like it's 30 milliseconds from my machine going and talking to the servers and back.
And then with Kestra also being designed for performance and speed, none of this gets in the way, right? It just, the data's ready to go. You never have to think about it because as soon as you make your request in Claude, the webhook here is triggered. You're making all the requests to Memento. The next workflow runs, but it all happens so quickly that it doesn't get in the way, which is quite useful.
Yes, and I did design everything to be async. So even if these tools were waiting for them to run, which they're not, but if they were, it wouldn't matter. It's running so fast, it would add negligible latency to the tools. But again, because it's designed the way that we have it here, it's all async. Nothing's waiting for these.
The rest of this workflow, basically, if that request comes back as not 200, aka doesn't exist, then it sets the header, and then what does that validate body at the bottom do?
So this is making sure that the body of the incoming webhook has all of the fields that I expect. So does it have a timestamp field? Does it have a tool name field? Does it have the success boolean indicating that tool successfully ran or not? And does it have the latency in there as well? So it's validating, do those fields exist? And then if they don't, it's actually going to delete the item potency key and say, hey, you can try again if you want. But if it does have all those fields, it's setting the outputs to those values and then successfully ending. Those outputs are then consumed inside of that other Kestra flow.
I think that gives a good summary of the metric webhook. So now that this workflow, let's say everything has gone successfully, the workflow has finished with a success state, we're now going to see the metrics workflow run. So let's have a look at that. And this is where your code that isn't code comes in handy. So you've got all these inputs to begin with, and all of these inputs come from your previous workflow. They're all part of that webhook trigger. If you go to the bottom of the workflow, you'll see that the flow trigger that you have that starts this workflow is just getting all those inputs from the trigger from the previous workflow. So basically everything's just getting handed over to this workflow so the operations can continue. All the data's there, it can get started, but it only does it if the webhook one finishes successfully, which is key because there's nothing worse than having this one waste a bunch of time just for it to fail. And then once it's got all of that data, it starts with all of your expressions. I've seen there's quite a few expressions in this workflow.
Yeah, there's a bunch. Yes, there's a bunch. So I'll walk through it. While it looks like a lot, it's really not that many steps. For me, explaining workflows, I prefer this topology view. That way I can talk to a little bit, and then we can come back if we want to go and see what the actual code looks like. So there's the trigger. And what we're doing in here is we're actually using two different cache keys inside of Memento. One, we're storing raw metric data as an array. So basically everything that comes in is getting appended to this array. So if I have 100 calls, 100 metrics that were sent to me, there will be an array with 100 metrics. So what we're doing here is we're first loading that array, and then we are adding the incoming metrics to that array. I left this in. This was just for me for debugging, logging the batch. And then after we add that to the array, we're going to save it back. So we've successfully added the new metrics to kind of that raw array of data and put that back into the cache for the next time we run. Then what we're going to do is we're going to get a list of all the unique tool names that have been run from that raw metric batch. And we're using JQ to do that. And then we're going to iterate over each one of those, because what we want to do is we want to get the average latency and the number, basically the rolled up summary for each specific tool. Because it doesn't really help me to have metrics across the entire thing, because I can't really identify the tools that are being used that are breaking or that are slow. So we're grabbing the unique values and then iterating over each one of those. You can see here in the topology view, it's an iterate, and we are grabbing all of the metrics for that specific tool, and then we're doing a hefty JQ expression to do some. We'll jump back to it in a second to do some math on those metrics, consolidating everything. So we have the output of this little loop here. We're going to consolidate the output into an array again. It gives us the rolled up summary of each one of our tools, and then we're going to save that back into Memento as here is the metrics for all of your tools. And that's what we're ultimately loading up in Postman, which is that overall, here's what you got. This is what everything is doing summary. So it's not that many steps, honestly. I mean, it looks like more because I left in some of my debugging steps on accident, but really it's not that bad. Load the values, append, save, get the unique tools, iterate over those, calculate some metrics, save the metrics.
I think, like you said, the topology YAML can be a little overwhelming when it starts to get quite long and wordy like this. But the topology view does a nice job of being able to kind of take you back to reality, right, and make you realize actually it's not really. It might look complicated, but it's actually, if you break it down, it's actually not too bad. And the topology view sort of helps to ground you and remind you what's actually going on when you might first open a workflow and go, I have no idea what I'm looking at right now.
For sure. It's hard, in my opinion. It's hard to talk to code. It's harder to talk to YAML because you know how opinionated developers are with YAML.
Oh, yeah.
I feel like just you either love it or you hate it. And talking to it, even if you love it, it's still hard to read. So talking to a diagram like what we have in the topology view is way easier.
Now, you're using a lot of, we call them expressions in Kestra, which is where those curly brackets have the yellow bits, basically. But you're also using some of the sort of Pebble expressions that I don't touch upon very often. So it's very interesting to see how you've been able to take Pebble even further. But the thing that's interesting about it is that while it's very easy to do some very simple things, it also seems to have no limit to a degree as well. It just kind of keeps going. If you can think of it, you can probably do it in an expression. And I can see that you're setting a load of values, you're doing some JQ. Yeah, there's a lot going on here. And how did you find that development process of trying to, I guess, both the figuring out if the expression was correct and also adding it into your workflow so that it could achieve the end goal?
Yeah, just pure honesty, it was not easy. And I have a lot of experience in AWS using VTL, which is Apache's version of Pebble. Basically, it's a velocity templating language, which is very similar to this. And I've been using it for years and it still sucks. And that is how I have familiarity with this concept, but it's one of the things that we talk about in the AWS community very regularly is VTL sucks to use. It's hard to debug. It's hard to kind of know what you can do because there is no IntelliSense. You have to just comb through logs. ChatGPT is not always very helpful when it comes to let me figure out what to do here. So, it's basically guess, check, repeat. That's really what I was doing. I had JQ docs up because I had to figure out what specific fields I wanted to do and what directives were supported inside of there. But I also had the Pebble documentation up because it's also using some of those. So really, I'm just setting the variables here and then using the real templating, the expressions down here to use those variables that I set. But this is not for the faint of heart. And in a production scenario, I wouldn't do this. This was me being hard-headed and saying, I don't want to write code. I really want to see if I can do this just in the templating language. And I proved, yes, that I can. But in a production scenario or I'm not the only maintainer of it, yeah, this is going to be whatever programming language my team uses.
Yeah, I don't see this very often from Kestra users. Never quite to this extent. So when I was reading this, I was like, interesting. I like it. It's different. But like you say, I guess the question I've got for you is if you were to write these workflows again, how would you approach it now after doing all of this?
Well, let me ask you a question, Will, because this is my first time in Kestra. And so I had some assumptions that may or may not be right. And I wanted to avoid additional latency by running scripts. So when you write a script, I'm typically a JavaScript developer. So if I wanted to write a little bit of Node, I know what that does in those tasks is, run that code in a container. And so what I was worried about and what I was trying to avoid was latency with getting those containers hot. And I don't know the rules around spinning those up and spinning those down. So really I decided to do this because in my head, I wasn't messing with additional containers.
Yeah, that's very smart. And we actually see that a fair bit where some people who are running lots of scripts, maybe lots of Python scripts or shell scripts or Node scripts, that turns into a lot of containers very quickly. It adds a lot of latency to their workflows because it's got to spin up the container, potentially download a Docker image. Yeah, just that process in its own can just make the whole workflow take way longer. And I actually did a video recently looking at the performance differences with like using a UV, which is a Python package manager. And if I was using the Docker, we call it a task runner, which is how you run your code. If I was using the Docker task runner, it took like twice as long, but there are definitely some benefits to running things in Docker, right? Let's not pretend that Docker's bad here, but in some scenarios, like what you're doing here, running everything in a Docker container is probably unnecessary and probably just going to add to your latency. So the other option is you can run it as a sub-process on the Kestra host. We call it a process task runner. If you're doing short things or stuff that's nothing super complicated, maybe doesn't have tons of dependencies, you just need to be able to run some code quickly. The process task runner is fantastic for that because it just runs the code. It's also really useful if you know you're going to use Kestra with a certain set of dependencies, maybe you know you're going to use a certain library, you can install that library as part of your Kestra instance so that your workflows already have access to that. If you're running it as a process task runner, it can already access those libraries. And so we've seen people who have like big Python operations, they don't use Docker task runners. They use everything in a process task runner, which they can set as a global default to make things a little bit easier. And then they install all of those Python dependencies that they just rely on all the time in Kestra. So it's managed in one place, because that's the other thing. If you've got multiple workflows as well, and they all have different dependencies, the problem you have is then each one's downloading, I don't know, Python pandas or, a Node package. And every time it runs, it's then reinstalling it or getting a new version. And you go, well, I just want the workflow to run. I'll deal with managing upgrades and stuff separately. I don't want it to do that when it runs the workflow, because now what was supposed to take under 10 seconds has taken half a minute because NPM is taking its sweet time to install everything. So there are ways around it. But again, it depends on what you're trying to achieve. If you want that key isolation, right, then Docker container is probably a good approach. But if that's not really that important, then the process task runner is definitely going to get you the better performance. So I guess if you were doing this again, doing it in Node or another scripting language of your choice, using the process task runner, because I imagine you're not really using any libraries. You're mostly just using JQ, right?
Mm-hmm.
Yeah, you could just install JQ on the Kestra instance, or you can install it before the process task runner runs, but also it will cache it. So in theory, if you use it between a different workflow, it will go, oh, it's already installed, so I'm just going to use it and just get on with it. So it will only be slow for that first installation. That probably would have made your life a little bit easier. And what I would recommend to someone watching this and thinking, I'd like to build something similar, I'd like to maybe interact with Kestra, don't be afraid to use the script tasks, but do be aware that there are different ways to run them so that they can run faster.
Yes, definitely didn't want to scare anyone away from using the script tasks. And with everything, it's a good reminder, with everything in computer science, it's all trade-offs. So what do you want to trade off here? You're trading off latency for ease of development, really, and maintainability.
Mm.
For me, if I was to do this again, I probably would do it in the same way because the latency on this is super, super small, and all I'm doing is data transformations.
Yeah, I bet it's like nothing.
It's nothing. And all I'm doing is data transformations. But if I'm doing anything that needed, serious gusto, yeah, I probably would have switched over to use a script. It's all running async anyway, so nothing is waiting. But I do like to, in demos, I like to run a tool and then immediately say, look, here's everything, instead of, waiting 30 seconds and getting that little bit of lag.
We'll have a look at your executions for the metrics workflow. I'm curious to see, we can see just how quick each of these tasks are running. Like they're not even taking a second. Like these tasks were just, even if you were using a script task, right, it would still probably take 2 or 3 seconds, right, to compile, depending on what programming language you're using, which is one of the benefits of Kestra. You can use whatever tools good for suits you. You might pick a certain language that's better for latency for what you're doing, or you might pick a language that's easier to write complicated things in. It might be slower, but it's easier to build. It depends what you're trying to prioritize, right? Performance or development time, right? But in this scenario, right, your development time might have taken longer than writing a script task, but look at that latency.
Yeah, it's hard to beat, really. And I am usually of the opinion where, yeah, I'll spend a little bit more time up front to do it. In this case, what I would consider right, and again, right is not the same for everybody. It depends. To me, right is the lowest amount of latency. So taking that development time up front to figure it out. And honestly, I'm building my skill set too. It's, a little bit of discovery, but now I can do it again a lot easier if I want to go and build something new.
To wrap things up, do you have any words of wisdom for people who want to get stuck in with MCP, as you've obviously played around with it a fair bit, not just in this scenario, but I know you've had a few other scenarios too. Any top tips for someone who's maybe just heard about it? They're like, it's all the buzz, I want to get involved, but anything to avoid, I guess? Anything you should know?
Don't just use anything that you find. I actually have a blog post that by the time this video airs will be published. I'm publishing it today about trust. And right now you're going to go and you're going to find a lot of websites that are just listing MCP servers that have been scraped out of GitHub. And there's no validation, there's no security checks, there's no authenticity validation. It's all just code that's put out there for you to use. And in many, many situations, these MCP servers that you're going to see are running locally on the client. So they're being downloaded and the code is running there, which opens you up for your credentials getting scraped, for keyloggers to be installed, for a whole bunch. It's an entirely new attack vector. So you have to be careful with what you're using. If you can, go for remote. Use remote MCP servers versus local. Now, you're not going to get access to your file system if that's what you're going for, which is what a lot of people are doing with their IDEs when they're trying to get enhancements when they're writing code. But if you're doing something with agents where it's more autonomous, try not to download them unless you absolutely have to and you can verify the authenticity of it. It's something that is getting put by the wayside right now because we're all trying to capitalize on the hype. And it's very scary because there's a lot of bad actors out there.
There's a lot of bad actors and there's a lot of hype around AI at the moment, and it's easy to get carried away.
It is. It's very easy to turn a blind eye when you're excited about something.
Thank you so much for joining, Alan. Really appreciate it. If people want to maybe find your blog or see some more things from you, where can they find that?
So everything that I create goes on my website, readysetcloud.io. I have a newsletter, I have my blog, I have a podcast. All of those things get rolled up onto that website. You can also find me on LinkedIn as well. Just search for my name, Allen Helton. I will likely be the first result that pops up. You'll see my face. So do reach out. I'm happy to talk about anything, be it workflow design, distributed computing, AI, API design as well. Big into all those things, and I've built my career around a majority of those things.
Thanks again, Alan, for joining us. And yeah, look forward to seeing some of your more blog posts in the future.
Thank you very much. Thank you for having me. I really appreciate the time.